On page 12, geometric transformation. So if you move this triangle 5 units to the right, draw it in its new location, record the coordinates of the vertices. Vertices are all the corners in the triangle. So first let's start with the original points of the triangle. What are the 3 points of the triangle? 2 of them are listed, we're missing 1.
3 and 2.
You're missing this one right here. You're missing 3 2s, so that goes in that third box. And we're going to move the whole triangle 5 units to the right. It's got 1 done for us. This one that's right here, we're going to move it 5 spots, is now going to be at 6 1.
9 2.
Okay, let's move the top one, 1 4. What are the coordinates going to be if I move it 5 spots to the right?
6 4.
Okay, put a dot at 6 4. Devin, you said 9 something?
What's here? 8 2.
Move this one over 5 is going to be 8 2. Now, if you connect the dots, should we still get a triangle?
Yeah.
Yeah, it should be the exact same shape, right? Just moved over 5 to the right. It says instead of keeping track of each individual point, which you did here, we can describe what happens to all the points. Here's one way to show the pattern. Our y stayed the same, so it's still the same number. Our y's were all the same number here. 1, 4, and 2. Our x's all moved. X's all got 5 bigger. 1 plus 5, 1 plus 5, 3 plus 5. Okay, so question number 2. Answer these questions about this transformation. What happened to all the x coordinates? What happened to the first numbers?
They stayed the same.
They did not. The first numbers did not stay the same. What happened to the first numbers?
They changed.
5?
5.
Yeah. They got 5 bigger. What happened to the y coordinate, the second numbers?
Stayed the same.
They stayed the same. Okay, move this heart shape down 5 spots. So why don't you see if you can move that shape down 5 spots.
Like, what does it mean? Like, go down by columns?
Move this thing down 5 spots.
Oh, did it? How did I end up upside down?
All right, number 4. Explain why it makes sense that the x-coordinates of the vertex points should stay exactly the same. Why did the x-coordinates not change? Remember, x means left and right.
Because it's going straight down.
It's going straight down. Okay, fill out the points. The point that was at 2, 6. Where is it now?
At 1,
1's not a point.
2.
2's not a point.
I don't know.
Well, points like this, Landon, you gotta give me 2 numbers.
Oh, 2 and 1.
2, 1. That point is now right here. 2, 1. Notice the pattern. X stays the same. The y is 5 less.
4, 3.
X stays the same. The y is 5 less.
4, 6. 4, 5.
X stays the same. The y is 5 more.
Sorry.
Wants to know where it started at.
5, 0. 3, -3. Y decreased.
You're close. What happens to all the x's?
Stayed the same.
So it's still x. Y decreased by.
5.
There you go. Do you have that, Sean?
Yeah.
All right, top of the next page. Apply this transformation. So now it's going to tell us we got to figure it out. Where are the x's moving to? Gotta tell me sooner. I'm going to go all the way through this paper.
All right.
How far?
15.
Yes. So it's moving 15 to the right. And
30.
what?
30.
30 which way?
Up and down.
Up. It's plus. All right, so look at this first point. We'll graph it here, but we'll come up with a point first. 15 to the right is now going to be at? Right now it's at 15. What's 50?
30.
Right now it's at -5. It's moving 30 up. 30 more than -5.
25.
Kira,
Yeah.
right now we're at 20. We're moving right 15.
Mm-hmm. 35.
Good. Landon,
What?
we're at -15. We're moving 30 up.
Positive 15.
Good. Madison, we're looking for what we started with, but I know when we added 15 to it, I got 45.
Oh, so it's just like.
Sean, what did I add 30 to get 10?
-20.
Good. Devin, 15 more.
35. 75.
Kira, what did I add 15 to get 25?
Ten.
10 plus 15. Landon, what plus 30 is 15? Okay, so here's all your new points. Put the dots on there. Note they do go by 5s.
It's case. I didn't have to look.
So put the dots, connect them.
reminds me of when I used to play connect the dots all the time.
Yeah?
Connect the dots is fun.
Again, your shape's got to look the same as what we start with. Keep that in mind.
Sort of. Sufficient.
The grid did go by fives there as well.
Oh, I'm trying to put you.
Good?
Nope.
Yes, sir.
Now I'm
If you want to really get fancy, you can kind of shade it in.
All right. Our teeth, though.
All right, question number 7. Use the following to show the transformation. Okay, so it wants us to write this about this information. So xy is going to, it says move the shape 14 left. So what would I do to my x to move it 14 left?
Move it 14 on the x.
Subtract or add?
Ah.
That would be right.
Oh, subtract.
Yeah. So I'm going to take x minus 14. How about up 8? What would I do to my y's?
Y plus 8.
Nope, add 8 to it. There you go.
I think I'm pretty competent with this.
Okay. Always do left and right first, so that's why I'm jumping ahead here. Left 15.
Minus x minus 15.
Subtract 15. Landon, how do you think I show down 12? What do I do to the y coordinate?
Make it a positive.
Subtract 12. Adding would be up. Subtracting would be down. Number 9. A classmate says when I look at xy, x plus 15, y plus 15, I think it means the shape becomes bigger because we're adding both x and y. Doesn't that mean the shape gets larger? Okay, so does this mean the shape gets larger because you're adding? No. All you're doing is moving the dots. This was plus 15, plus 30. All it did was move the dots right 15, up 30. Our shape stays exactly the same because you're moving every dot. So, no, it doesn't get larger. You are moving each vertex, each point, however you want to say that. All right, question number 10. Who wants it?
Me.
Sean. I am point E. My x-coordinate is 3. So, of course, we're going to put that in for x. My y-coordinate is 1 less than my x-coordinate.
2.
Tell me where to put the dot. And label it
Label it E.
E. Very good. Who wants 11?
Me.
Landon.
Alright.
Read it.
My coordinates is -1.
Pretty good.
Huh?
Good.
Y equals -3x.
Okay, so what's negative 3 times x?
-3.
Nope.
Positives.
Nope. Negative 3 times negative 1.
1.
Oh,
3. 1.
3.
3. I said 3.
It said I could also go left 4 and up 1. It'd be the same point as what you just wrote down. Landon, that didn't count. You're going to do 12.
Okay.
Come on, Lando.
I'm getting there. Alright. So start at M
Okay.
and use the rule xy and then xy minus y.
Okay, so what happens to my x?
It becomes a 1.
No. What happens to my x?
Stays the same.
All right, so not moving left and right at all. What's this mean?
It means you just stay at that point.
No, it doesn't. It's minus 5, Landon. 1, 2, 3, 4, 5. Landon, what point is that?
-2.
What?
-2.
No. Landon, I need 2 numbers for a point.
Yeah.
-2 is not 2 numbers.
Let me put the dot.
No, that is not where I put the dot.
It's -1 and -2.
It's -1, -2. I need 2 numbers.
I said -2.
Yes, but that's not 2 numbers. I tried to tell you that. 13.
Technically,
Kira.
it's two.
Okay.
It's got 2 numbers.
You want to start at E or start at O?
What?
We're going to get to the same spot. Pick one. E or O?
Oh.
Okay. How are we moving? It says X plus 3. So I move. It says I'm hard. No, X is left and right. I move 3 to the right. My Y doesn't change. So there's my dot.
That's it?
That's it. I don't know why we're making this so hard. X means left and right. Y means up and down.
This is hard.
No, it's not.
Parts of it is hard. I understand where to put the dot.
See, now there's 4 pages. And you said
Next page.
there would be like,
You design a video game in which there is a rocket traveling around the screen. The player touches the screen where they want the rocket to go. And your game keeps track of the rocket's movement. To do this, follow the rocket around the screen by drawing on the grid and write the algebraic expression. So it says pick a point on the rocket. They already did that.
Wow.
-3, -6. That's this dot right here. If I move it 4 to the right, where will it go? Where will it be at? 4 to the right.
That'd be 6-2.
Nope.
6-1.
Nope.
6-3.
Nope.
Wait, 6-4.
Nope.
What?
Would be 2-6. Or 1-6, I mean.
It'd be right here.
I understand backwards.
5, 4 to the right. 1, 6.
Wait, I'm done. My bad.
Okay? From 1, 6, count 9 down.
-3.
Good. From there, move right 2 and up 1.
-2, +3.
Nope.
+3, -2.
From there, move 3 left and 4 up.
negative.
I got 0-2.
0, 2.
Yep, so it says I got
You said negative. Move 5 left.
-5, 2.
You said -2.
Good, -7.
5 left. 1, 2, 3, 4, 5.
Will you use a 5?
I did. Okay. So from there, let's draw a rocket. That's where it moved to. That's this point and this point. So let's see. 1 left and 2 down. 1 left and 2 down. Put a dot. There's the first part of the rocket. I then go 1 down. Put another dot. 1 to the left. Down 1. Right here. Looks like 1.5 to the right, and I'm just following this pattern. 1.5 to the right, up a half, down a half, 1.5 to the right, up 1, left 1, up 1, connect the dots.
I did it.
My rocket is so beautiful. Can I show it on the screen?
No.
I'm gonna travel to Mars.
Why Mars?
All right. We're not going to do a test point here. You could do a second one if you want. We're going to figure it out with only one test point. Okay, what happened to my X? Move to the right 4. What does that look like?
X +4.
Did my Y change?
No.
No. Now the next one, the Y changed. How far did the Y go down?
9.
Y went down 9.
Can you zoom in?
Please. Now, can you zoom in?
What?
All right. This one says to the right 2. So if I go right 2, what's this going to change to?
Oh, plus 6.
That means I want a total of 6 now. And up 1. I got a -8. What's 1?
-9.
Negative 7.
Oh, this should be -9 here, guys.
So -10.
It's down 9.
Oh, negative 8.
-8 would be 1 higher than -9. What's the next line say?
Move
3 still added.
Okay, so what's 3 off of this?
3.
What's 4 above this?
4. -4.
-4.
Number 5 to the left.
And the last one.
Yes.
5 left.
-2.
5 left of this.
-2. And -1.
This doesn't change. Did not go up and down at all on that last step.
Oh.
All right, to write one instruction then. All those steps when that person was pushing on the screen can be simplified into one step. And check and see if it makes sense. From this initial dot, 2 left and 4 down. Do you get to your drawing if you go 2 left and 4 down?
Yep.
It means you got it right.
Homework?
No. I want to do one of 17 or 18 before we do some more translations.
No,
Do 17.
Who wants 17?
Me.
Me.
18?
Me.
Devin? Case.
What?
17 or 18?
18.
We're going to do 18.
Wow. Betrayal.
All right, I am divisible by 6. So 6 goes into this number. These two added together will equal these two added together plus 1. Sum of my digits is 9. They all add up to 9. Same thing about multiplying here. H times U is the same as HT and U. Well, that tells us what T is. What could you multiply by that would not change your answer?
1.
So you know that's 1. My tens digit is 1 less than my units. So that means you know the units digit.
2.
And now it says to add up all the digits equals 9.
6.
6. Plus 1 plus 2 is 9. Very good. Next page. Just some translations here. Use the graph to help you determine the rule. Okay? What happened to my graph here? What happened to my picture? You can pick any point and look at it.
It's on the negative side.
What happened? Where did it move? What direction did it move? Huh?
It
Move 3
moved.
to the right.
3 to the right. I agree with that. So what are my dots at? 3 to the right is only going to affect
Plus.
my X digit. So I'm
Okay.
going to write down all the Y's. Because they are not changing. Go ahead now, Sean. Now I'm ready.
Positive 2.
And?
0.
Nope.
Oh, I didn't. My bad. Positive 1 and. Positive 1 and negative 2. And then. Positive 3. And then negative 3. And then x plus 3.
Very good. So all that changed was your X coordinate. So all I did was add 3 to the first numbers. You could also have figured out every dot over here, but hopefully you're figuring it out. It's easier than that. Question 20. Went from the gray to the purple. Which way did it move and how far? Gray to purple.
It went 2 down. Oh wait, yeah, 2 up.
2 up.
2 up.
So your X is not changing, so I'm leaving that the same for all of them. And all my Y's then are going to get 2 bigger. So 2 bigger than 0,
2,
2 bigger than -2,
0,
2 bigger than -3,
-1.
2 bigger than Y.
Y plus 2.
Good. The last one changes both ways.
2 to the right, 1 down.
Move to the right 3, down
4 to the right, 1 down.
4 to the right, 1 down. Is correct. Okay, so all my X's get 4 bigger. Landon, 4 bigger than -1.
Negative, no, positive
4 bigger than -2.
2.
4 bigger than 0.
4.
4 bigger than X.
X.
4 bigger than X.
Oh,
X
4.
plus 2.
Plus X plus 2.
X plus 4
Or,
is 4 bigger than X. Kira,
oh boy.
Y's are down 1. So 1 less than 0.
-1.
1 less than -2.
-3.
1 less than -3.
-4.
1 less than Y.
Y.
Y minus 1.
Plus.
22, I am point A. Y coordinate is 3. Okay. Looks like I got 2 answers here, so I put a 3 in for both of them. My X coordinate satisfies something squared equals 16. There are 2 possible places I could be. Mark them both. So what squared is 16?
4.
And?
And -4.
Good. 4, 3. -4, 3. My X coordinate makes the following solution. 15 minus X is 12.
3.
3. My Y coordinate is the opposite of X.
-3.
I am point C. Use B to get to me. X minus 5, Y plus 3. So start at B. What's X minus 5 mean?
Subtract. Go left 5.
Left 5.
So.
What's Y plus 3 mean?
Up 3.
Up 3. Where am I?
-2, 0.
-2, 0. And you'll notice if you have one of these points off, they're all going to be affected. If B's in the wrong spot, you can't get to C. I am point D. My X coordinate is a solution. 10Y plus 4 equals 34. So what plus 4 is 34?
30.
30. So what does Y have to be to give you 30?
5.
20.
You're multiplying. 10 times what is 30? That's what it's asking you. 3. Okay, what's your X coordinate?
X plus Y equals 5, so it has to be 2.
Y is 3. What plus 3 is 5?
2.
2. 2, 3 is letter D. And the final one, Landon. What squared is 36? And?
And 1
-6.
or -6. No, because yeah.
What squared is 1?
1.
And?
-1.
And it says there are 4 possible places where I could be. There they are. 6, 1. 6, -1. -6, 1. -6, -1. There are the 4 points E could be.